All right, let's talk about AI hallucination. It's one of the biggest, most talked about challenges in AI today. We're going to break down what it really is, and more importantly, how we can start to manage it from a system level perspective. So let's just dive right in because this is the question on everyone's mind, right? We hear this word hallucination all the time. It almost sounds like we're accusing the machine of, intentionally making stuff up. But what is actually happening under the hood when an AI gets something wrong? Is it just a bug, or is it something much, much deeper? Well, to really get our heads around this, the first thing we've got to do is get the definition right. We need to stop thinking about this as some kind of moral failing and start looking at it for what it is, a technical problem. Now, look at this definition carefully. This is where it gets really interesting. It doesn't use words like false or lie. The key phrase is not sufficiently supported. This completely shifts the frame. The problem isn't that the AI is necessarily wrong, it's that it failed to connect its answer back to solid proof. And that leads to a pretty wild conclusion. It means we can't solve this problem just by dumping more or even cleaner data into the model. You could train an AI on a library of perfect, verified facts, and it could still hallucinate. That tells us the real issue isn't the data, it's the architecture. It's a system design problem. Okay, so this is where we really start to break things down. To tackle this, we have to realize that not all hallucinations are created equal. They actually fall into two completely different buckets. On one side, you have what we're calling controllable hallucinations. You can think of these as system flaws. They're mistakes that pop up because of bad design choices, which is good news because it means we can actually engineer our way out of them. But on the other side, you have unavoidable hallucinations. And this is where it gets weird, because these aren't bugs at all. They're actually a core feature of learning and intelligence itself. So let's tackle that first bucket, the controllable ones. These are the problems that we can and we absolutely should be solving right now. A huge source of these controllable errors comes from something called input under specification. Basically, it happens when we let someone ask a vague question. I mean, imagine asking a legal AI, is this case a valid precedent, without saying for which court? The AI has to guess. Or take this example. Is this polymer biodegradable? Sounds like a simple question, but scientifically, it's completely useless. I mean, think about it. Biodegradable where? In soil? In water? Over a month or over a century? At what temperature? Without all these specific conditions, the AI has no choice but to assume the context. And that assumption, right there, is a silent, hidden hallucination before the model has even generated a single word. So how do you fix this? Well, you design a system that just refuses to guess. By forcing the user to provide what's called a minimum condition set, or MCS, the system demands a specific, well-defined question. And just like that, you take away the model's need to assume anything. Its drop shifts from guessing to actually reasoning within clear boundaries. And once you start thinking this way, you realize this system design approach solves a whole bunch of other controllable errors too. Things like the AI grabbing evidence from the wrong context, or taking a finding that's true in one specific case and acting like it's a universal law. It's all about building smart guardrails into the system itself. Okay, so we can fix the system flaws. That's great. But here comes the twist. What about those hallucinations we can't get rid of? The ones that are actually a feature, not a bug. This is such a cool idea. It turns out that the very things that make an AI so powerful, its ability to learn, to generalize, to spot new patterns, are the exact same processes that create these so-called unavoidable errors. And it happens for a few key reasons. First, these models are probabilistic machines. They're not built to say, I don't know. They're built to give you the most likely next word. Second, to be any good, they have to generalize. They have to make educated guesses about stuff they've never seen before. And third, learning is a process of compressing reality. And anytime you compress something, you lose a little bit of detail. Which brings us to this really powerful idea. That act of guessing, of extrapolating beyond the known data, is basically a form of controlled hallucination. And if you're trying to do something like discover a new drug or a new material, that leap into the unknown isn't just helpful, it's absolutely essential. So once you see it that way, everything changes. It leads to this really practical, powerful shift in how we should be building these AI systems. Our entire goal needs to be different. This right here, this is probably the most important takeaway. The mission is not to build a perfect AI that never ever guesses. That's impossible. The mission is to build an honest AI, one that tells you exactly when it's stating a known fact and when it's making an educated guess. So here's the game plan for how you actually do that. You build a 3-layer system. First, at the input layer, you get rid of all the ambiguity. Then, at the evidence layer, you only pull data that strictly matches those very specific inputs. And finally, at the output layer, you clearly label everything so the user knows exactly what they're looking at. So what does an AI built on this idea actually look like in the real world? Well, the difference is night and day. Forget thinking about it as a chatbot. We're talking about upgrading it to a precision scientific instrument. You know your typical chatbot, right? It's designed to be a confident know-it-all. You ask it a question, and it gives you a single, polished answer that sounds like the absolute truth. It hides all the uncertainty, all the nuance, all the context. But a system designed for discovery, it behaves completely differently. It's more like a careful lab partner. It will tell you, okay, here is what is directly supported by evidence. Then it'll say, based on that, here's what we can infer might be true. And crucially, it will also tell you, and here is what is still completely unknown. It's totally transparent about where the facts end and the guessing begins. And that is the big transformation. With this kind of thoughtful system design, the thing we were calling hallucination, that inferential leap, is no longer a dangerous hidden error that could lead you astray. It becomes an explicit, clearly labeled hypothesis. It becomes an idea that you now can take and go test in the real world. Which really just leaves us with this final thought to chew on. What if the real path to trustworthy AI isn't about building models that are perfect and never make a mistake? What if it's about building models that are just perfectly honest about when they might be wrong? How would that change everything?